Hello, and welcome to the third edition of the IOA Video Bulletin. I'm your host, Rich Keeble, back again to hear what's buzzing in the world of acoustics. Let's take a look at what's coming up.
Straight away, bring the research work I'd done on diffusing surfaces into the design of this new opera house.
There are many studies that show that diverse organisations are more profitable than those that aren't so diverse.
In the upcoming years, we're going to have drones, we're going to have urban mobility vehicles or flying taxis.
If something like a new runway gets discussed, then this is a group that would consider the evidence.
Another exciting challenge was the design of outdoor performance garden. The stage has been designed to sit below the street level.
The models that I used during my PhD were good. However, that more research is required in looking at the hierarchical cost structure of materials.
And I think one of the things we have to do is to think hard about how we increase the supply of people in the future as enabling technology industries overall.
We could predict not only the species richness, the number of different bird species, but we could also predict really strongly the actual habitat itself.
We're also trying to minimize this effect using some advanced like signal processing and AI technology, for example, machine learning algorithms.
I've done a number of times already, so as you might imagine, there are quite a few things that I've discovered that I can't talk about.
This is an exciting time for the Institute. It's a time of opportunity.
From our investigations, the noise problem is from the chiller plants with insufficient isolation supports.
First, to tell us about his exciting work with theatres and music venues is Prof. Orlowski. Hi, Raf. Now, you've worked in both research and consultancy. What did you find most interesting about each career?
Now, in teaching, it can be very interesting and rewarding. We meet first-year undergraduate students who only just got a smattering of acoustical knowledge, and then 3 years later, they leave with a degree in acoustics, fully equipped to enter the acoustic profession, and it's nice to have played a small part in their career trajectory. I'm particularly interested in acoustics of spaces for the performing arts, and so I was researching into surfaces for diffusing or scattering sound, and also methods for accurately measuring sound absorption of elements in auditoria. I was very fortunate in having some brilliant research students helping me with this research work. One of those was Trevor Cox, who produced an outstanding PhD thesis and then went way beyond me and became an authority on the subject and wrote books on it and so on. Another one of my postgraduate students was able to validate a method for measuring the sound absorption of seating, which has become an industry standard now. So that is very satisfying to work with these bright postgraduate students. And incidentally, two of my former students have become presidents of the Institute of Acoustics, and a third of my postgraduate students is currently president-elect of the Institute. So that's kind of nice. When you're interested in auditorium acoustics, you have a desire to actually get your hands dirty and design some spaces and seeing them being built. And that's why I moved from academe, although not entirely, into acoustic consultancy. And my first job was to help with the design of an opera house. And the architect for that project decided he wanted to adopt a circular geometry for the opera house, surmounted by a dome, which of course has serious acoustical focusing problems. So I was being able to straight away bring the research work I'd done on diffusing surfaces into the design of this new opera house to actually counteract the focusing of the circular geometry. We brought in this new method of measuring seating absorption very accurately. So that was a very important thing in getting the reverberation time we were looking for. And it was a different experience from academe. We were dealing with other members of the design team, architects, mechanical engineers, theatre consultants. We had to understand what their requirements were for the design of this new opera house. They had to understand our requirements. So it was a collaborative effort in making sure all these requirements came together and produced the final design. And of course, on opening night, it can be quite nerve-wracking. But after a successful first night performance, where the audience and the performers have clearly enjoyed themselves, it can be a rewarding experience.
So you moved into consultancy because of your passion for performing arts venues. Have you seen many changes in the last 45 years?
I think there have been a lot of changes in the design of the acoustic design of spaces for the performing arts. If we go back to the early 1950s, for example, when the design of the Royal Festival Hall was being developed, all the acoustical knowledge that was then available was applied to the design of the festival hall. And the focus was really on getting the reverberation time right. But that knowledge at that time was not sufficient to guarantee a successful outcome in terms of acoustic quality. And in fact, the reverberation time turned out a little bit short. And that was partly due, in fact, to not being able to measure the seating absorption accurately, which I've already mentioned. And remedial measures were necessary to improve the acoustics. Not long afterwards, in the 60s and 70s, there was a flourishing of research in auditorium acoustics, focusing really on the way that reflections were arriving at the listener and the direction from which the reflections were coming from. Also around the 1960s, a new form of concert hall was developed in Berlin. It's called the Berlin Philharmonie, where the architect decided to place the audience close to the center of the concert hall and surround the audience, surround the orchestra with audience, sort of seated on terraces, a little bit like the terraces you get in vineyards. And so this type of hall became known as the vineyard terrace type of hall. And that form of hall has been copied many times since then, and it's still popular today. Since the design of the vineyard terrace hall or the surround type hall, there are two sets of opinions amongst acousticians as to which form produces the better acoustics. Is it in fact the vineyard terrace form, or is it the traditional rectangular narrow shoebox form? And there's yet another group of acousticians who think we should really be developing a new form. So in the fairly recent new concert hall in Paris, the Paris Philharmonie, a new form, a new typology was developed called the bicameral hall, which has two chambers, the inner chamber providing the early reflections and the outer chamber providing the reverberance. So there are several different opinions amongst acousticians as to which form of concert hall is the best. And that's why the Institute of Acoustics, every 2 years or so, holds a conference on auditorium acoustics. So all these acousticians from around the world can come together and discuss which type of hall is best. And the conference is always arranged in a new venue. Next year in 2023, it's in the Stavros Niarchos Opera House. So as well as the papers and the discussions, there'll be an opportunity to listen to a performance in the new Opera House and discuss that as well.
Thank you, Raf. Next to update us on the government's sound developments is Peter Rogers. Hi Peter. Now, what is APPG and why is it needed?
Okay, so the APPG is an all-parliamentary group, and it's a cross-parliamentary group of people that are focusing on sound, and in this case, we want it to be sound, noise, and health to tackle the issues of the day as they arise, and so that basically we can have a proper forum for politicians to understand what goes on in our wonderful area that is called acoustics. Well, society is basically getting busier, and noise has been an issue for a long time. And it's been initially it was thought there was just an irritant and something that needed to be dealt with as a consequence of effectively the Industrial Revolution. But the evidence now in terms of health and well-being is growing to a point where we can't ignore it anymore. And that is the environment that you encounter on a daily basis affects how you feel, how well you are, how you age, how well you sleep, all those sorts of things. And as a result, it's a massive public health issue. And consequently, those that represent us need to understand that topic. And it only really makes sense when you start to talk about some of the issues that we've got. So when you think about the cities and our cities, and the idea that you're trying to sleep in an environment that is actually pretty hectic, then when you're designing new places, new homes, hospitals, schools, all those sorts of things, if this issue isn't dealt with properly, then you get poor health and well-being outcomes.
What are your hopes for the future of APPG?
So first and foremost, it's first creating a forum for proper science to be informing decision makers. So if something like a new runway gets discussed, then this is a group that would consider the evidence base that then is used for decision makers to make decisions. So whether it be House of Commons, House of Lords, and actually all of the parties to be able to then formulate their own policies, ultimately it means that we should end up with a better environment to live in, and that's critical.
Thank you, Peter. According to a McKinsey report, companies in the top quartile for racial and ethnic diversity are a whopping 35% more likely to have financial returns, above their respective national industry medians. Furthermore, teams with a diverse gender profile are also 15% more likely to outperform the median. The combined result of improving both racial and gender diversity is a 25% net increase in performance. To tell us about diversity in the acoustics field is Angela Lamacraft. Hi Angela. How diverse is the acoustics industry at present, and why do you feel diversity is important?
At the moment, we're not doing too well on diversity. We have just over 3,000 members. 15% are not male, 17% are not white British, and only 4% declare some form of disability. Compared to the UK workforce as a whole, that's not great figures. There are many benefits to having a diverse membership for the Institute. So first and foremost is collective intelligence. If we have people from a broad range of backgrounds, then we're more likely to know what questions to ask for our clients and for the population as a whole when it comes to acoustic needs. Then there's the issue of profitability. So whilst the Institute isn't a profit-making organisation, it is important that we balance our books. And there are many studies that show that diverse organisations are more profitable than those that aren't so diverse. So, for example, if we can improve the diversity for the Institute of Acoustics, we will hopefully be able to tackle problems in many different ways and improve profitability for the Institute. So by improving diversity and improving the number of people that come into the industry from different backgrounds, we will hopefully be able to plug the gap in the skills shortage. Then there's the moral reasoning. It just feels like the right thing to do. People should be able to join the acoustics team regardless of their background.
And what can or is being done to improve diversity in the acoustic industry?
We set up the Institute of Acoustics Equality, Diversity and Inclusion Working Group last year, which I'm really privileged to chair. We've done a number of things so far. For example, we've put together a list of specialist societies for protected characteristics. We are publicising awareness days, weeks and months. So for example, this month is ADHD Awareness Month, and one of the working group members put together an article about ADHD. We've also undergone EDI training in the working group, which we're really hoping the Institute leadership team will repeat at the end of this year or beginning of next year, because we have a new president for the Institute. Members of the working group also presented at Internoise, which was a really large conference this year, and we helped the Early Careers group with the Institute's first ever buddy scheme, which went down really well and helped people who are a bit nervous about attending a conference to take part. We're hoping to educate our membership about various issues, for example, unconscious bias or microaggressions or specific needs of underrepresented groups. We'd also really like to see better visibility of underrepresented groups in the leadership of the Institute, for example, on groups and branches committees. We're helping groups and branches and the meetings committee to provide more inclusive meetings as well. For example, thinking about timings of meetings, thinking about the venues of meetings, and even thinking about the areas where social events are taking place. We know that there's no quick fix for improving diversity and inclusion in the industry, but we're hopeful that all the small things that we're doing will add up and that in time we'll have a far more diverse and inclusive industry.
Thank you, Angela. Next, sharing the hum from the transport sector is Dr. Antonio J. Torija Martinez. Hello, Antonio. What projects are you working on at the moment?
So one of the projects I'm working on at the moment is on drones, drone noise. So we are developing protocols for doing measurements, how to do measurements, acoustic measurements of drones. And also we are in the process of, we are doing some research for understanding how drone noise is perceived. The idea is to develop metrics so we can do a more accurate assessment and management of environmental noise due to drone operations. The other project I'm working on is on electric scooters. And in that case, what we are doing is developing an optimized artificial sound to be added to electric scooters in order to increase vehicle noticeability. So we want to make pedestrians aware of the electric scooter approaching. Our focus is mainly on blind and partially sighted communities because they might be more affected by the lack of sound from these electric scooters. So our main goal here is to contribute to the wider adoption of these micromobility vehicles by adding an awareness sound that doesn't contribute necessarily to increase noise pollution.
How are rapid changes in the transport sector affecting the acoustics industry?
So currently we have more and more electric vehicles coming into service. So the implications of that is that, for example, we are experiencing a decrease in ambient noise in our cities because of the introduction of electric engines. So we are getting rid of a little bit of road traffic noise due to engine operations. In the air, we have, in the upcoming years, we're going to have drones, we're going to have urban mobility vehicles or flying taxis. And those are going to be new sources with, it's expecting for them to have tonal noise, high frequency noise, and therefore they will be highly noticeable by communities. And for that reason, we could have a significant issue due to community noise impact and increasing community noise impact due to the operation of these vehicles. So in summary, I see that the introduction of e-mobility vehicles is going to significantly change our current soundscapes in the urban environments. And one could think of probably one of the biggest changes in the soundscape we have experienced in the last few decades.
How does e-mobility provide an opportunity to change the way in which we address environmental noise problems?
Because it's new, so it's a new source. We have different challenges. We have different operations, operating capabilities. So for example, you can think of a drone. Usually, if you put the focus on aviation industry, you have an aircraft flying from airport A to airport B, and the well-defined operational procedures. In this case, we are going to have potentially more vehicles flying closer to communities, probably more dispersed, although there will be, of course, some corridors for these vehicles to operate. So it's completely new. So we are at this opportunity of why don't we do things differently? Why don't we try, for example, to include acoustics just at the beginning of the design process? Why don't we try to employ metrics accounting for in a more accurate way of how people perceived noise? In this case, for example, employing some sound quality metrics that are accounting for different audio features representing the way we listen, we perceived sounds. So in summary, because it's a new source, we are at this opportunity to do things differently, and we can be working with other engineering fields just at the start of the design process for these vehicles.
Thank you, Antonio. Onur Gulen has made a video about the changes in room design acoustics from the days of King James I to today. Let's take a look.
The Shakespeare North Playhouse is a unique project which sees plans by the famed 17th century architect Inigo Jones. With authentic materials, dimensions, and staging arrangements, it gives a truly authentic Jacobean playhouse experience, but with optimized acoustic conditions that modern audiences expect. Room acoustic design of the Cockpit Theatre presented an exciting challenge, as the structural timber frame left very little space for acoustic treatment to be incorporated. Also, any acoustic finishes needed to be invisible, so as not to detract from the Shakespearean environment. Heavy acoustic curtains have been included in our design to allow variable acoustic conditions for different stage configurations. The octagonal ceiling was also optimized to improve reflections from the stage, especially during the in-the-run stage configuration. Here, ceiling can be adjusted to change the effective room volume by the use of trapdoors, which can be opened and closed during performances. Another exciting challenge was the design of outdoor performance garden. The stage has been designed to sit below the street level to benefit from additional shielding from external noise sources and to protect audience members from traffic noise in a busy town center location. Smoke extract strategy of the new building required large openings on the noisiest facade. This made it difficult to control very low internal background noise levels of NR25 within the theatre. Therefore, high-performance smoke vents have been incorporated in our design with a sound lug type air gap. The council hopes that it will regenerate the Prescott area, expecting more than 100,000 visitors a year. Benefits would also include new high-quality jobs and business investments.
Very interesting. Last year we spoke to Hasina Begum, who was studying for her PhD about scientific models and the study of aerogels in vibroacoustic applications. Hello Hasina, What have you been up to in the last year?
So since we last spoke, I completed my PhD at the University of Sheffield. Since then, I was able to look at new aerogel technologies used in the form of composites. I've discovered that the models that I used during my PhD were good. However, that more research is required in looking at the hierarchical structure of materials. So this is something that we discovered, and we realized we need a better model to use in our validation process. In terms of the materials, aerogels themselves are quite fragile, and they don't have very good mechanical stability. So we're looking at using new processes to measure those mechanical properties like strain and modulus. And I looked at using them in different physical forms, so in granular, monolithic and powder forms, and applied them to different applications like buildings and pipes. From then, I stayed on as a visiting academic at Sheffield, and I ended up working for a company in fiber optics, where so it was still in acoustics. So I looked at implementing optical fibers in pipes and looking at the strain and how we can measure water flow and turbulence. And then from then, I actually realized that I didn't like working in industry so much. So I decided to apply for a fellowship. So I applied for the Marie Curie Fellowship, which was in Switzerland, and I'll find out the outcome of that in 6 months' time. But I've actually been offered a job at Warwick University looking at composites and automotive, so slightly different. I'm really looking forward to starting there. I'll be starting there in a few weeks, and I'm excited to use my current understanding of acoustics and composites and try and implement that into a new application, which is automotives now.
Thanks, Hasina. Also back again with an annual update is Dr. John Lincoln. Hi, John. How is the current economic situation affecting the acoustics industry?
I think, like all enabling technologies, we have some very interesting challenges in the economic environment. We have some supply chain issues that are still revolving around the world on trying to get chips or particular pieces of control electronics. Those are getting better, but still slowly. So for those people making equipment, those are issues. And then, of course, we have most recently economic turmoil that impacts exchange rates. They, of course, impact our cost of imports of technology into the UK, but they make our exports very cheap. But they overall deliver an uncertainty domain where investment becomes more problematic. And I guess in particular for acoustics in the built environment, rising interest rates can have an issue on what may be happening in the built environment.
And what impact do you think the supply of people will have on acoustics?
Well, one of the interesting things, of course, is that we currently have slightly contradictory economic indicators. So we've seen record employment levels recently reported in the UK. Yet at the same time, we're hearing people talk about high interest rates inducing a recession, which normally indicates unemployment rising. Those two contradictions make it a very interesting time to be running a business, because most people, if they're hiring people, are finding it hard to find the talent they want, where they want, at the price they want. And on the other hand, we're being told, actually, people will be readily available. Those two things don't really square. And I think one of the things we have to do is to think hard about how we increase the supply of people in the future as enabling technology industries overall, and how we can make it clear for young people, say, working in acoustics is a way of working in the high-tech industry and has really interesting career options, rather than just saying, we're going to go and get the people from another industry over there. That cannibalization doesn't work if everybody's short. We need to be really focusing on how you grow the overall talent pool and keep them in the industry or in the industries that are most interested in, and make sure they have the most vibrant opportunities available to them.
Thank you, John. Breaking ground with new technology in the field of acoustics is Yicheng with his study of pipe bots. Hello, Yicheng. How did you get involved in this area of research, and what exactly is a pipe bot?
Hi, Richard. I'm doing postdoc at University of Sheffield as a member of researcher for PipeBots project. So PipeBots is a robot which can be used in sewage pipe or water pipe. So for sewage pipe, it's trying to find out is there any defects or other like condition monitoring inside sewage pipes. Whereas for water pipes, the PipeBot is trying to find other like defects, for example, like leakage or cracks. I'm trying to use like acoustic sensing technology to adopt on this robotic platform to find out is it a blockage or is a leakage there in the pipe. So it's mainly about the physics understanding of the wave propagation inside the pipe. For example, in sewage pipe, there must be some like surface roughness inside the pipe or some other like pipe connections. So all these discontinuities or surface roughness of problems can affect the wave propagation. So we are trying to understand how these uncertainties may affect the acoustic sensing. And we're also trying to minimize this effect using some advanced like signal processing and AI technology, for example, machine learning algorithms to sort of classify the blockages with a more accuracy rate.
Thank you, Yicheng. Next to tell us about the ecological role of soundscapes is Alice Eldridge. Hi Alice. What is the ecological role of soundscapes and how can this research be applied?
Well, I'm working within the emerging discipline of ecoacoustics, and within this frame, we see sound as an ecological resource. So like food or habitat, we think of sound as an ecological resource. Examples of what our data is. These are our soundscapes. So there's some recordings from reef systems. And a lot of our work has been done in terrestrial ecosystems, in forests. Soundscape then is a source of information about the ecological status of that ecosystem. And with contemporary hardware and a bit of maths, then we have potential for a cost-effective ecological monitoring tool. We're really familiar with the idea that animals make sound, right? The discipline of bioacoustics has studied kind of individual calls between birds and insects and bats and even more recently fish and whales. But we now understand as well that not just these individual calls, but the soundscape as a whole, so all of the emergent sounds in a particular place are also kind of key ecological information. These soundscapes themselves are important kind of ecological information, if you like. So a frog chorus by a pond might be used as a cue for other frogs to navigate towards that potential site as a potential site for reproduction. Or it might be used by some migratory birds that are trying to maintain a particular route, you know, as towards a breeding territory, for example. And it's not just the animal kingdom that makes sounds, right? Flowers respond to pollinator sound. Within minutes of a bee buzzing past, they increase the sugar concentration in their nectar. And we know also that plants emit information when they're stressed. They emit airborne sounds under stress. So the application then is we switch this round. We can say, if sound is central to staying alive, then we can listen to the sounds of being alive, if you like. At the simplest level, we have unintentional sounds. So we can listen in soil and we can hear worms and beetles moving around. We can listen in reefs and we can hear the crackling of cavitation bubbles of snapping shrimp, or even pondweed. In evolutionary terms, if we think sound is essential to survival, then organisms need to be heard. And so just as we have niche partitioning, we're familiar in ecology with the idea of a niche in terms of our habitat or the food that we eat, we also have acoustic niche partitioning. And this leads to this idea then that a higher biodiversity would have a higher kind of acoustic diversity, right? And then using machine listening tools, using computational analysis, we can analyze those soundscapes and get some sense of not just the individual species, but the kind of community as a whole. So to focus in on some of the work we've been doing at Sussex, some years ago now, back in 2014, I was working with a brilliant conservation biologist, Dr. Mika Peck. He works in frontline communities in the Amazon or in Southeast Asia. working with local communities at the front line of climate change. So he's interested in cost-effective tools for biodiversity monitoring. Now, we can use satellites, we can use remote systems, right? They're more cost-effective than humans, ecologists going in and measuring things on the ground. The problem with satellites is obviously light is blocked by the canopy or by the soil or by the sea. The good thing about sound then is that sound is omnidirectional. We can listen in all light levels, and we can listen below the canopy and below the earth and below the water. The first work we did back in 2014 was to ask the simple question then, if we record the soundscapes across woodlands and forests of different ecological status, we'll see a gradient of species diversity, the difference in birds. Can we analyze the soundscapes and use that to predict the species diversity, the species richness? And what we found back in 2014 is that we could do that with surprising accuracy. We could predict not only the species richness, the number of different bird species, but we could also predict really strongly the actual habitat itself. So in the UK, we worked in some ancient woodland, in some regenerating rewilding project, Nep Estate, and also in a farmland, a barley farm. And then we also worked in Ecuador in the Amazon, where we similarly worked in a pristine rainforest, a regenerating forest, and in another oil palm plantation. And we can see these gradients of ecological health, if you like. We measure that traditionally with species richness. And what we showed is that actually, if you calculate a bunch of acoustic descriptors that they might be familiar with in speech processing or music information retrieval, then we can really accurately predict that habitat health. With this hardware and some new mathematics, we can build a kind of stethoscope, if you like, for the planet. I think of it almost like a baby monitor, listening in to how the planet's doing, both in terms of those critical last remaining areas of wilderness and also these numerous global restoration rewilding projects that are taking place. So we want to use this technology to protect and regenerate and build evidence for these restoration programs. But actually, just listening to these soundscapes, the data itself, if you like, also helps us reconnect with the Earth. And that might sound quite sort of hippie, but I do think we need to shift from this mindset of ecosystem services, of thinking that the planet is something that we need to use and recognise ourselves as part of that larger pattern of life.
Thank you, Alice. Next to tell us about underwater acoustics is Professor Gary Heald. Hi, Gary. What made you choose underwater acoustics and sonar as your field of research?
I grew up in Weymouth in Dorset, which is quite near to Portland, which is where the Admiralty Underwater Weapons Establishment was situated at the time. My father was actually in the atomic energy establishments, but at the age of 13, I discovered amateur radio, which of course is all about radio waves. But I got heavily into sort of interest in waves and the electronics of both radar and radio and things like that. I went on to do a degree in applied maths, actually. AUWE being local, I found myself working with a number of the companies who supported the Ministry of Defence back then. And so I was doing a lot of electronics in the first part of my career, but I got very interested in sort of underwater propagation, scattering, target scattering as well, obviously, for obvious reasons. So that was really the evolution. And to be honest, I happened to date Dennis Stansfield's daughter, a well-known transducer expert at AUWE, and he sort of encouraged me as well. And then in 1993, I was working on site for the Ministry of Defence, and they basically said, have you ever thought about joining? Which is when I joined what was DRA then, and then DERA, and then subsequently DSDL.
What's been your most exciting discovery so far?
Okay, I've mentioned the MOD a number of times already, so as you might imagine, there are quite a few things that I've discovered that I can't talk about in this forum because they're at secret. I mean, until I partially retired from the MOD recently, I was running things like the Sonar Modelling Handbook, which of course is allowing our sonars to measure their own performance and to assess how they might achieve detections in given environments. I'm probably best known for the topic that I did my PhD on and then got the A.B. Wood Medal for, and I've carried on doing research in this, and that's for sediment classification. So it's converting the acoustic scattering from the seabed to say what is there in there that you can actually pull out to say that this is sand, this is mud, this is rock. And I actually set a facility up at Bath University, which is still there to this day and being used, which has got 4 different sediment trays. So that's got cobble, gravel, sand, and then a sort of muddy silt at one end. And I'm aware that one of the French PhD students, Irene Moppen, has been there recently using that. But I've always had an interest in inverting acoustic signals. So my last PhD student at Heriot-Watt University, she was doing something similar, but with materials. So we used dolphin chirp signals or something similar to dolphin chirp signals. And we were able to tell the difference between a sphere made of copper, of aluminium, of stainless steel and of brass, and then filled it with different things like air, water, sand, and oil, and we could tell what the material was. In fact, there's an IET paper out there that came out on that a couple of years ago. So that's the inversion of acoustic sounds is probably the thing that I'm best known for.
Thank you, Gary. Next, we have Alistair Somerville to tell us about the key areas of opportunity for the IOA. Hi, Alistair. What areas of opportunity do you see ahead for the IOA?
There are huge opportunities for the Institute at the moment, and sometimes significant events can overtake us, and as a direct result, we're forced to review what we do, how we do, and develop new ways of working, and COVID did that for all of us. I would hope that we can develop to better engage and expand our sphere of influence in government and public circles. We've just set up a new sound, noise and health group, and I'm looking forward to this group developing an important contribution in influencing research and decision making, which will be to the benefit of all in terms of health and well-being outcomes. I'd also like to further develop and reshape our educational services delivery, looking at the subject areas that we cover, the qualification levels that we offer, the flexibility of study options, and even the geographic accessibility to our courses. We've recently been impressed by the number of international students who feel that they want to undertake our diploma course. What I'd also like to do is to develop and improve our engagement with and influence in international acoustics platforms. We have a Vice President International who is going to be heading up on that, and we're looking forward to planning ahead to get more engaged with our international partners. I'd quite like to broaden the appeal of IOA membership to professions that maybe are underrepresented. And I'm particularly thinking of those working in academia at the moment. We've introduced a new research grade of membership within the Institute, and we're hoping that that will encourage academics to get involved in the Institute and also look forward to providing what they need. Also like to expand our sphere of influence in primary and secondary schools. We have been for many years now sponsoring Edinburgh Science to deliver acoustics STEM activities in schools and in school competitions. And I'd now like to see this work developed further. I've got a trial project at the moment where we are setting up acoustics hubs in schools, where a lead school would act as a hub to enthuse and engage with other schools and higher education and acoustic professionals. And it's hoped that this would highlight the very many pathways to rewarding careers in acoustics. As an institute, we should be seeking to perform all our functions in a sustainable way, and we've appointed a sustainability champion to guide us through that process. And we're also looking to make use of a net zero toolkit to further promote our sustainability credentials within the Institute, and also try and influence our members and our member organisations to do the same. So to summarise, this is an exciting time for the Institute. It's a time of opportunity for change, for looking at what we do and how we do it. And in all these aspects, I'm looking forward to developing the institute for our members, for our engagement with the public, and in terms of expanding our spheres of influence internationally and domestically.
Thanks, Alistair. Cheung made a video about how he solved noise problems in a Hong Kong hotel. Let's take a look.
I'm Yicheng, Senior Acoustics Consultant in AECOM Acoustics. We were appointed by a management team in the hotel in Hong Kong to solve the existing tonal structural noise problems in the guest room just under the chiller plants in the mechanical plant rooms. From our investigations, the noise problem is from the chiller plants with insufficient isolation supports. In this case, one of the conventional ways should be replacing all the spring isolators to solve these problems. However, it's impossible for the operating hotel to suspend their chiller plants in a considerable period to make such modifications. With these constraints, we thought tuner mass damper could be a device able to suspend some vibration energies on the source rather than to find different solutions to further isolate the vibrational motions transmitted to the building structures. Therefore, we will design a prototype of soft bridge type tuner mass dampers to carry out the in situ tests to verify whether these ideas works or not. It consists of a 40mm solid stainless steel rod and two collars at the controlling mass. The natural frequency of the system can be fine-tuned by adjusting the location of the collars on the rod. From the results of our tests, each of the prototypes could reduce near 70% of vibration accelerations and 10 dB tonal noise level reduction in the guest room when all 4 prototypes were in place. After the test, our clients is quite surprised and impressed that we were able to find an easy and cost-effective solution they have never seen before to solve this tricky noise problem.
Well, it's been an interesting programme so far, hearing all the buzz in the field of acoustics from the acousticians themselves. That sound means it's time for Sound Flash, the latest news from the world of acoustics. Saturn V was loud but didn't melt concrete. The Saturn V carried man to the moon and remains the most powerful rocket to successfully launch into orbit. Multiple internet claims about the acoustic power of the Saturn V suggest that it melted concrete and lit grass on fire over a mile away. But such ideas are undeniably false. Researchers used a physics-based model to estimate the rocket's acoustic levels and obtained a value of 203 decibels, which matched the limited data from the 1960s. So, while the Saturn V was extremely loud, that kind of power is nowhere near enough to melt concrete or start grass fires. Scientists invent quantum flute that can make particles of light move together. Physicists at the University of Chicago have invented a quantum flute that, like the Pied Piper, can coerce particles of light to move together in a way that's never been seen before. Associate Professor David Schuster's lab works on quantum bits. Just like in a musical instrument, Schuster said, you can send one or several wavelengths of photons across the whole thing, and each wavelength creates a note that can be used to encode quantum information. The researchers can then control the interactions of the notes using a master quantum bit, a superconducting electrical circuit. But their oddest discovery was the way the photons behaved together. In nature, photons hardly ever interact. They simply pass through each other. With painstaking preparation, scientists can sometimes prompt 2 photons to react to each other's presence. Here we do something even weirder, Schuster said. At first, the photons don't interact at all, but when the total energy in the system reaches a tipping point, all of a sudden, they're all talking to each other. Warming oceans are getting louder. According to a new global study by the National Institute of Oceanography and Applied Geophysics, climate change will significantly alter how sound travels underwater. Potentially, this will affect natural soundscapes as well as accentuating human-generated noise. These changes to ocean soundscapes could impact essential activities of marine life. 2 acoustic hotspots of future sound speed increases are predicted east of Greenland and in the northwest Atlantic Ocean, east of Newfoundland. In these locations, the average speed of sound is likely to increase by more than 1.5% if business-as-usual high rates of greenhouse gas emissions continue through 2100. Fibre optic sensing detects a tremor from Icelandic subglacial volcano. Research published in the Seismic Record indicates that the floating ice cap, part of the Vatnajökull glacier, acted as a natural amplifier of the tremor signals generated by the Grímsvötn volcano, one of Iceland's most hazardous. After analysing the densely sampled DAS data, the researchers realised that the floating ice sheet was acting as a natural resonator of seismic signals, allowing them to detect the volcanic tremor that might have otherwise been overwhelmed by other ambient or instrument noise in a traditional seismic network. This appears to be the first observation of a floating ice sheet acting as an amplifier of tremor, said Andreas Fitchner, a professor of seismology and wave physics at ETH Zurich. In addition to providing information about the underlying processes, tremors may also serve as a precursor of volcanic eruptions that should be monitored closely. And that's it from the 3rd edition of Sound Flash, and brings us to the end of this episode of the IOA Video Bulletin. We hope you've enjoyed hearing the groundbreaking buzz from the world of acoustics and are looking forward to more in the next episode. But until then, keep quiet and carry on.